The use of number 14 wire rated at 105 degrees Celsius in a device drawing 16 amps continuously is a potential fire hazard. Number 14 wire is rated for a maximum of 15 amps under the conditions specified in the National Electrical Code, or NEC. When electrical current exceeds the rated capacity of a wire, it can overheat, causing insulation to degrade and potentially leading to electrical fires. The use of number 14 wire in a single-phase heater rated for 4000 watts appears to be a design flaw. Marley's installation and maintenance instructions explicitly state number 14 wire is appropriate only for the 3-phase model, which has a lower power rating. The omission of specific wiring instructions for the single-phase model suggests a potential oversight or error in the design process. Firstly, it is important to report the potential fire hazard and design flaw to Marley's engineering department. Request clarification on the appropriate wire size for the single-phase model. Secondly, if Marley does not provide a satisfactory response, consider rewiring the heaters with number 10 wire to ensure compliance with NEC standards and reduce the risk of fire. Thirdly, closely monitor the heaters during operation for any signs of overheating or electrical issues. Fourthly, install smoke and carbon monoxide detectors in the rooms where the heaters are located for early detection of any potential hazards. The NEC is a minimum standard. Local building codes may have more stringent requirements for electrical installations. It is always advisable to consult local authorities and follow all applicable codes and regulations. The ampacity of conductors, or the current carrying capacity, is governed by NEC Table 310.15b16. This table provides ampacity values for various conductor sizes based on their insulation type and installation conditions. For example, a number 14 copper wire with a typical insulation like THHN is generally rated for 15 amps when used in residential or commercial applications at an ambient temperature of 30 degrees Celsius. However, several factors can affect this ampacity rating. Firstly, the insulation temperature rating. Wires are insulated with materials that can withstand specific temperatures. Common insulation types include THHN, THWN, and XHHW. A wire rated for 90 degrees Celsius can handle higher temperatures than one rated for 60 degrees Celsius, allowing for a potentially higher ampacity under certain conditions. The 105 degrees Celsius rating is better than some, but it might still not be enough. Secondly, ambient temperature. Higher ambient temperatures reduce the ability of a wire to dissipate heat, thus lowering its ampacity. NEC Table 310.15b16 provides correction factors for ambient temperatures above 30 degrees Celsius. Thirdly, the number of conductors in a raceway or cable. When multiple current-carrying conductors are bundled together in a raceway, cable, or conduit, the heat generated by each conductor can raise the overall temperature, reducing the ampacity of each wire. NEC Table 310.15 cone provides adjustment factors for this situation. For example, if you have 4 to 6 current-carrying conductors in a raceway, you must stare at the ampacity of each conductor to 80% of its value. Fourthly, termination temperature. The terminals of electrical devices such as breakers, switches, and receptacles are often rated for specific temperatures, typically 60 degrees Celsius or 75 degrees Celsius. The wire must be sized so that its ampacity at the termination temperature rating is sufficient for the load. This means that even if the wire insulation is rated for 90 degrees Celsius, you must use the ampacity value corresponding to the termination temperature if it is lower. In this specific situation, the heater is drawing 16 amps continuously, which exceeds the standard ampacity of a number 14 wire rated at 15 amps. Even with a 105 degrees Celsius rated wire, exceeding the ampacity can lead to overheating, insulation breakdown, and potentially a fire. The NEC addresses continuous loads in section 210.19a on which states that branch circuit conductors serving continuous load shall have an allowable ampacity not less than 125% of the continuous load. A continuous load is defined as a load where the maximum current is expected to continue for 3 hours or more. In this case, with a 16 amp continuous load, the conductor must be rated for at least 16 amps times 1.25, which equals 20 amps. Therefore, our number 14 wire, even if rated at 105 degrees Celsius, is not sufficient because it is not rated for at least 20 amps. Using a number 10 wire, as previously mentioned, is a more appropriate choice since it has a higher ampacity rating, typically around 30 amps, depending on the insulation type and installation conditions. Always consult NEC Table 310.15b16 and the associated correction and adjustment factors to determine the correct wire size for a given application. If the heater is rated at 4000 watts at 220 volts, the current draw can be calculated using the formula power equals voltage times current, or current equals power divided by voltage. So, 4000 watts divided by 220 volts equals approximately 18.2 amps. Given that the measured current draw is around 16 amps, this is within a reasonable range considering potential voltage fluctuations and manufacturing tolerances. To further elaborate on the design flaw aspect, electrical appliances and equipment must be designed and tested to meet specific safety standards such as those set by underwriters, laboratories, or UL. These standards ensure that the product is safe for its intended use and that it does not pose a fire or electrical hazard. When a product is UL listed, it means that UL has tested a representative sample of the product and determined that it meets UL requirements. Part of this testing includes verifying that the wiring within the device is appropriately sized for the current it will carry and that it can withstand the expected operating temperatures. If the Marley heater is using number 14 wire for a single-phase model that draws 16 amps continuously, it raises questions about whether the design meets UL standards or if there was a discrepancy between the design specifications and the actual product configuration. In this situation, contacting Marley's engineering department is crucial because they can provide insights into the design rationale and any potential deviations from the intended specifications. It is possible that there was an error in the manufacturing process or that the wiring configuration was inadvertently changed. Furthermore, consulting with a qualified electrician is highly recommended. An electrician can perform a thorough inspection of the heater installation to ensure that it complies with all applicable electrical codes and that the wiring is properly sized for the load. They can also assess the overall safety of the installation and provide recommendations for any necessary corrections or upgrades. Additionally, carefully monitoring the heaters during operation is essential. Look for any signs of overheating, such as discoloration of the wiring, melting insulation, or unusual odors. If any of these signs are present, immediately turn off the heater and disconnect it from the power supply. Do not attempt to repair the heater yourself unless you are a qualified electrician. Instead, contact a professional for assistance. Installing smoke and carbon monoxide detectors in the rooms where the heaters are located is a critical safety measure. Smoke detectors can provide early warning of a fire, while carbon monoxide detectors can alert you to the presence of this odorless, colorless gas, which can be produced by malfunctioning heating appliances. Test the detectors regularly to ensure that they are functioning properly and replace the batteries as needed. The NEC is updated every 3 years, so it is essential to stay informed about the latest requirements and best practices. Local built-in codes may also have specific requirements that are more stringent than the NEC, so it is always advisable to consult with local authorities and follow all applicable codes and regulations. Rewiring the heaters with number 10 wire is a proactive measure that can significantly reduce the risk of fire. Number 10 wire has a higher ampacity rating than number 14 wire, which means that it can safely carry more current without overheating. When rewiring the heaters, use the same type of insulation as the original wiring and ensure that all connections are made properly. It is also important to use appropriately sized circuit breakers to protect the wiring from overloads. The circuit breaker should be sized to match the ampacity of the wire, which in this case would be 20 amps for number 12 wire and 30 amps for number 10 wire. If the circuit breaker is too large, it will not provide adequate protection against overloads, which could lead to overheating and a fire. Also, consider that the 105 degrees Celsius rating of the wire's insulation is a key factor, but it does not override the fundamental ampacity limitations dictated by the wire gauge and the NEC. The high temperature rating allows the wire to operate safely at high temperatures without degrading the insulation, but it does not increase the amount of current the wire can safely carry. The ampacity of a wire is primarily determined by its cross-sectional area, which is directly related to its gauge. A number 14 wire has a smaller cross-sectional area than a number 12 or number 10 wire, and therefore it has a lower ampacity rating. Even with a 105 degrees Celsius insulation rating, a number 14 wire is still limited to 15 amps under normal conditions. When dealing with electrical installations, it is always best to err on the side of caution and to use wiring that is appropriately sized for the load. Using undersized wiring can create a fire hazard and put people's lives at risk. By following the recommendations outlined earlier, you can help ensure the safety of your electrical system and prevent potential fires. Remember to contact Marley's engineering department, consult with a qualified electrician, monitor the heaters during operation, install smoke and carbon monoxide detectors, and rewire the heaters with number 10 wire if necessary. Additionally, keep in mind that electrical codes and regulations may vary depending on your location, so it is always important to consult with local authorities and follow all applicable requirements. The NEC provides detailed guidelines for electrical installations, including wire sizing, overcurrent protection, grounding, and bonding. It is essential to familiarize yourself with the NEC and to follow its requirements to ensure the safety of your electrical system. The NEC is updated every 3 years to reflect changes in technology and best practices, so it is important to stay informed about the latest revisions. In addition to the NEC, local building codes may also have specific requirements for electrical installations. These codes may be more stringent than the NEC in some cases, so it is essential to consult with local authorities and follow all applicable requirements. When installing electrical equipment, it is important to follow the manufacturer's instructions carefully. The manufacturer's instructions will provide specific information about the equipment's installation, operation, and maintenance. Failure to follow the manufacturer's instructions could void the warranty and create a safety hazard. It is also important to use the correct tools and equipment when working on electrical installations. Using the wrong tools or equipment could damage the wiring or create a safety hazard. Always use insulated tools when working on electrical circuits to protect yourself from electric shock. Before working on any electrical circuit, always turn off the power at the circuit breaker. This will prevent you from getting shocked or injured. Test the circuit with a voltage tester to make sure that the power is off before you start working. If you are not comfortable working on electrical circuits, it is best to hire a qualified electrician. An electrician has the training and experience to safely and correctly install and repair electrical equipment. Working with electricity can be dangerous, so it is important to take all necessary precautions to protect yourself and others. By following these safety tips, you can help ensure that your electrical system is safe and reliable. When assessing the fire hazard, it is critical to consider the specific installation conditions and the environment in which the heater is operating. For instance, if the heater is installed in a confined space with limited ventilation, the ambient temperature around the wiring may be higher than normal, which could further reduce the ampacity of the number 14 wire. Also, if the wiring is routed through insulation or other materials that impede heat dissipation, this could also contribute to overheating. In addition to the continuous load requirement, the NEC also addresses the issue of voltage drop in branch circuits. Voltage drop occurs when the voltage at the load is less than the voltage at the source due to the resistance of the wiring. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends that the voltage drop on the branch circuit should not exceed 3% at the furthest outlet. To minimize voltage drop, it is important to use wiring that is appropriately sized for the length of the circuit and the load it is serving. In the case of the Marley heater, using number 10 wire would not only increase the ampacity of the wiring but also reduce the voltage drop, which could improve the heater's performance and efficiency. Furthermore, it is important to ensure that all electrical connections are properly made and that they are tight and secure. Loose or corroded connections can create resistance, which can lead to overheating and a fire. Use appropriate connectors and terminals for the wire size and type and tighten them to the manufacturer's specifications. Periodically inspect electrical connections to ensure that they are still tight and secure. If you find any loose or corroded connections, tighten them or replace them as needed. Grounding is another important aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, which can help prevent electric shock and reduce the risk of fire. All electrical equipment should be properly grounded in accordance with the NEC. The grounding conductor should be sized according to the size of the circuit conductors and should be connected to a grounding electrode, such as a ground rod or a metal water pipe. Bonding is the process of connecting all metal parts of an electrical system together to create a low impedance path for fault current. Bonding helps to ensure that all metal parts are at the same potential, which can reduce the risk of electric shock. All metal enclosures, raceways, and equipment should be bonded together in accordance with the NEC. Surge protection is another important consideration for electrical safety. Surges are transient overvoltage events that can damage or destroy electronic equipment. Surges can be caused by lightning strikes, power grid switching, or other electrical disturbances. Surge protective devices, or SPD, can help protect your equipment from surges by diverting the excess voltage to ground. SPD should be installed at the service entrance and at any sensitive electronic equipment. Arc fault circuit interrupters, or RFCs, are a type of circuit breaker that can detect arc faults, which are a common cause of electrical fires. Arc faults occur when there is an unintentional arc between two conductors or between a conductor and ground. RFCs can detect these arcs and trip the circuit breaker, which can help prevent a fire. The NEC requires RFCs to be installed in many locations in the home, including bedrooms, living rooms, and dining rooms. Ground fault circuit interrupters, or GFCIs, are a type of circuit breaker that can detect ground faults, which occur when there is an unintentional path for current to flow to ground. GFCIs can detect these ground faults and trip the circuit breaker, which can help prevent electric shock. The NEC requires GFCIs to be installed in many locations in the home, including bathrooms, kitchens, and outdoor areas. Electrical inspections are an important way to ensure that your electrical system is safe and code compliant. Many jurisdictions require electrical inspections for new construction, renovations, and additions. An electrical inspector will examine your electrical system to ensure that it meets all applicable codes and regulations. If the inspector finds any violations, you will be required to correct them before the electrical system can be approved. Hiring a qualified electrician is always the best way to ensure that your electrical work is done safely and correctly. An electrician has the training, experience, and knowledge to handle all types of electrical work. When hiring an electrician, be sure to check their qualifications and licensing. Ask for references and check their insurance coverage. A reputable electrician will be happy to provide you with this information. Working with electricity can be dangerous, so it is important to take all necessary precautions. Never work on electrical equipment unless you are qualified and authorized to do so. Always turn off the power at the circuit breaker before working on any electrical circuit. Use insulated tools and wear appropriate personal protective equipment. If you are not sure how to do something, ask a qualified electrician for help.